of the lecture, earthquakes. So, Aditya, look front now. Parinita, look front. So see here, till now we have discussed the earth. It is made up of three layers. We have discussed three layers: crust, mantle, and core. These are the three layers. Now see here. On top we have the lithosphere. We have the lithosphere. Lithosphere, it consists of crust and some part of mantle. It consists of crust plus some part of mantle. That is top layer, which is solid. The solid layer, that is called as lithosphere. Lithos means stone. The solid layer, that is called as lithosphere. It consists of crust and some part of mantle. So below lithosphere we have one more layer, asthenosphere. We have one more layer called asthenosphere. Asthenos is a Greek word. It means soft. That is, it's a soft layer. Yes. So see here, on top we have one layer. It is our lithosphere. It consists of crust and mantle. So its thickness is how much? Around 40 to 80 or 90 kilometers. 40 to 60 kilometers you can take. So around 60 kilometers we take it. It varies because wherever we have the continents, it will be more thick. Wherever we have the oceans, it will be less thick. Crust, what was the thickness of crust? 14 to 16 kilometers. And lithosphere, it consists of crust plus some part of mantle. So its thickness will be more, around 40 or 60 kilometers. This is clear? Or 70 kilometers as well, it can be somewhere. Now 80 kilometers as well, it can be. Yes, that's fine now. Now below it we have one more layer, and its thickness is around 100 to 250 kilometers. Around 250 kilometers we have usually taken. And this layer, here mainly the radioactivity takes place. So heat is being released. Because of that, temperature rises up to 1300 degrees Celsius. It is believed that here the temperature is about 1300 degrees Celsius. So here most of the rocks melt. Most of the rocks melt. Here we have the solid as well as liquid part. So we call this as semi-molten. It is semi-molten layer. A part of it has melted, and other part that is in solid form. So it has solid as well as liquid form. So we call it as semi-molten layer. This is semi-molten layer, or we can call it like a plastic layer. This is our plastic layer. So asthenosphere, it means, asthenos is a Greek word, it means soft. It is our soft layer. Now see what happens. This lithosphere, this solid part is floating over the liquid semi-molten layer. This lithosphere, the solid part, it is floating over the semi-molten layer. So it will move. The lithosphere moves. It floats over. So see here. Here we have the semi-molten layer. Here the convection currents will be there. Convection currents will be there. And lithosphere, we have seen, it is made up of different plates. That is, a part of land is there, then another part of land is there. You can see in diagram as well. Figure 8.3, 69. Different plates are there. Asian plate, African plate. Biggest is the African plate. It's very old plate. Page number 69. See, these are, so lithosphere, it is different plates. They are interacting with each other. Now see what happens. On top, we are having lithosphere, solid part. And here we have asthenosphere. Here convection currents are there. So it means there is very slow motion of the material. In asthenosphere, it is semi-molten layer. There will be slow motion of materials. Slowly it is moving, very slowly it is moving. Since as it moves, what happens, the lithosphere floating over it, it as well moves. For example, this is the convection current. It means it will push the lithosphere to move in this direction. So this lithosphere moves. And one more convection current we have set here. And this is one plate, another plate. This is the boundary of these two plates. So on this boundary, these two plates will interact. Since both, this is the convection current. In this direction, it is moving. So these plates will move towards each other. These plates have to move towards each other. So they interact with each other. As they interact, what will happen? There will be tension created. Earthquakes will take place. So see how earthquakes are generated. So because of these slow convection currents, these plates interact. As they interact, what will happen? Either these plates will strike with each other. They will glide with each other. As they glide, waves are generated. Those are called as earthquakes. So depending on the intensity, how they are gliding. If they are gliding more, the earthquakes will be more severe. If there is very less interaction, it will be very small tremors will be generated. That is very small shocks, very less. So that's how the different kinds of earthquakes are generated. That is very less severe, more severe, depending on the interaction between the plates. This is one of the main reasons. That is, between the interaction of the plates, shocks will be generated. Okay. Now see here, these interactions, for example, this is our continental. Here we have continent. This is oceanic plate. This is our continental plate. So what will happen if they are interacting? Either they glide with each other, or one plate can go under the other. One plate can go under the other plate. Video is there. Okay. No, it's on. So other plate, the oceanic plate, it can go under the continental plate. So it is called as subduction. Subducting, it is moving under the oceanic plate, under the continental plate. So see here what happens. We'll be discussing along with the volcanoes as well now. So see here, for example, this is our continental plate. And here we have the oceanic plate. Now see here what happens. Oceanic plate, it subducts under the continental. So these are the convection currents. So it moves below. It is as well interacting. So it pushes these rocks. Tension is created. It pushes these rocks. Now each rocks, they are having some strength. That is, rupture strength is there. Like till what amount of stress these rocks can tolerate. Okay. Now these tensions start to generate. Rocks start to fold. Here these rocks start to fold. So syncline and anticline, they will be formed. Rocks start to fold. As they start to fold, mountains start to build. More folding, more mountains, height will increase. That's how Himalayas are formed. So folding starts to take place. Now see what happens. The stress generated in those rocks increases. It is increasing continuously as it becomes more than the rupture strength of these rocks. These rocks will rupture. Cracks will be generated in these rocks, and these rocks ruptures. Fractures will be generated. That is called as fault. So first folding takes place, then fault. As fault takes place, what happens? Rocks will again try to shear. Whenever we give stress to any object, the object tries to maintain its original position. It will struggle to maintain its original position. So now it starts to fold. As the stress generated, it becomes more than the rupture strength of these rocks. These rocks release the stress. They break, cracks will be there, they fracture, and they will release the stress. And this release of energy, this release of stress, this release of energy is in the form of waves. And these waves are called as seismic waves. And these are called as, this is how earthquakes are formed. Quakes are formed on earth, earthquakes. Any doubt you have, raise your hand. Yes. They are there. Depending on what kind of, here the radioactivity is going on. If it is less, very less convection current. More convection current. They are mainly always present. See here. Okay, I give you one example here. One example I am giving you. You can see the African plate. Yes, I don't want to hear no. You can see in the book. African plate you see, Eurasian plate you see, in between Europe and Africa, you can see the Mediterranean, and on the side you see the Red Sea, Africa and this Arabian plate. Just Shad, one more time you speak, you out of the class. No discussions in class. So you can see the African plate, this is Eurasian plate. Now see here, convection currents are there always, and these plates are moving towards each other. So they will, in future, the Mediterranean Sea will be closed. And here, Arabian plate is there and the African plate. They are moving apart. So Red Sea, it will increase in size. Yes, this is how, as well. See here, one more example. I give you Eurasian plate. We have the Indian plate as well. We have. So these plates were far away earlier. Indian plate. It was part of Australia, Gondwana land once. So it has moved towards Asian plate. With time, it has moved towards Asian plate and strike with the Asian plate and subducting. Now see here, this is how Himalaya, and it is subducting more and more. And Himalaya's height is increasing and increasing. It's increasing. So they are moving towards each other more and more. That's why these. Yes, it is increasing. It is continuously increasing. The height is continuously increasing. Yes, listen, one more thing I tell you about this. In Himalayas, we haven't have good intensity, high severe now. There gap, seismic gap is there. So we are hoping that in future there is a huge earthquake. Soon it is going to take place. In future it may happen. It has been long due. This earthquake has been long due there in Himalayas. Now see what happens more here. Yes, look here now.
There are mountains, and if there will be no mountains, then only plate length will be there, then how it will go?
Whenever these two are interacting, there was water between Indian plate and that was called as Tethys Sea. Tethys Sea. Now they move towards each other. The sea was closed, no more sea, and now the mountain starts to build. Initially they were lands. They start to build with slow process, and they are increasing in size. Yes. Now back to lecture here. Shekhar, Shekhar, pay attention in class. Leave those. Just pay attention. So pay attention here. Now see afterwards. Yes, now see here, back to the lecture. Rest of the doubts we will take after the class. So now see what happens. This is subducting. As it subducts, it is moving down. Now temperature increases here and it starts to melt. This rock as well starts to melt, and here pressure is generated. Since it is moving down, here the pressure is generated, and we have the magma, semi-molten rocks. They and here we have already discussed that rupture starts to build, cracks will be there, weak points will be there, and from them lava may erupt. Magma erupts and lava comes out. This is how volcanoes are formed. This is why we can see that wherever volcanoes occur, mainly earthquakes as well occur. The places where the earthquakes happen, more volcanic activity may be there. Most probably there is there. Wherever the volcanoes are there, earthquakes are there. So mainly the locations wherever we have the earthquakes, we have volcanoes as well. So they accompany each other. And where they do take place, wherever these plates interact, that is the weak points. The boundaries of these plates, we have the volcanoes and earthquakes. So when we discuss the distribution of the volcanoes or the earthquakes, they occur mainly at the same place. Along, we will be discussing that one afterwards. This is clear. So volcanoes, weak points are here, volcanoes occur here. Here are the interactions. So earthquakes as well happen here. They are related mainly wherever the volcanoes occur. Wherever there is a weak points in the earth, from there magma can erupt. And where are the weak points? Wherever these plates interact, those are the weak points. The boundaries are the weak points. Or wherever the rocks, there is a tension, there is stress in the rocks where they can break. As they break, cracks are there, fractures are there. From these are the weak points. From these, magma can erupt since high pressure is there deep inside the earth. So that's why volcanoes and earthquakes, they occur mainly mostly at the same location. And we'll be discussing that distribution as well soon. This is clear. So this release of energy in the form of seismic waves, this is called as earthquakes. Now see here, wherever this rupture has taken place, that is called as focus. Focus is the origin of the earthquake. Focus is the origin where these rocks have ruptured, where these waves have generated. That is the focus. So here the focus is there. It is below the earth. Now see here, as the depth decreases, focus will be more towards the earth's surface. More the shallow the focus is, more severe the earthquake will be. If it is more at more depth, less severe earthquake will be. So shallow earthquakes, they are more severe since the focus lies just below the surface, not much at depth. So if it is 60 or 70 kilometers just below or 40 kilometers, we have severe earthquake. And see here, and the point just above the focus, that is called as epicenter. Epicenter lies on the surface of the earth. Focus below the surface where the rupture has taken place, where the this energy is being released. Now just on the surface, we have the epicenter above the focus. So for example, these are the rocks. Here are the boundary interactions, and here the rupture has taken place first and crack has been generated. This is called as focus. And here on the surface, this is called as epicenter. This focus is also called as hypocenter. It's not given in book. This is epicenter on top, on the surface. Now these waves are related. These waves, the waves which travel in the earth, that is which travels in the lithosphere, these are called as body waves. These can travel here, they can go as well on the towards the core as well, they move on the other side as well, they move. As they keep moving away from the focus, their intensity decreases. So these are called body waves, and we have the surface waves as well. They are generated on the surface. There are 4 kinds of waves that is not in syllabus: PSLR. Primary, secondary, love waves, Rayleigh's wave. Primary waves, secondary waves, love waves, Rayleigh's wave. Now see here, these are body waves, these are body waves, these are surface waves. And most disastrous are these love waves. Most disastrous waves are these love waves. See here how. Okay, these 2 waves I won't be discussing. Love and Rayleigh's waves I will be discussing. See here. So ground will be shaking. Ground starts to shake. So if the ground is shaking like this, if the ground is shaking like this, then these are called as love waves, and they will shake down they will weaken the foundation of the building. So buildings can collapse. Rayleigh's waves, they are in the form of water ripples. These waves are clear. Now, Rayleigh's, Rayleigh, Rayleigh's wave. Yes. So focus epicenter is clear. Now causes of earthquakes. Causes of earthquakes. First we are discussing tectonic plates we have discussed. Tectonic means building activities. Plates we have already discussed that the earth's surface, that lithosphere is divided into different land masses which are interacting with each other. Whether they are moving towards each other, that is convergent. Convergent. And if they are convergent, they will be colliding with each other. As they collide, one may subside under the other. That is, subduction is taking place. Or this interaction can be gliding type. Transform interaction it is called. They can glide with each other. Or these plates, they move away from each other. They move away from each other. As they move away, this is called as divergence, diverging. As they move away, again the weak points are generated and volcanoes erupts, and here it brings a new landmass. So this divergent, when the plates are diverging, it is called as constructive because lithospace being created more. It is constructive, whereas subduction, it is destructive. Okay, so now volcanic activities, how volcanic activities leads to earthquakes. As we know, as the volcano erupts, volcano eruption as well we discussed, it can be quiet, it can be explosive. Silent, I already said. It can be quiet, it can be explosive. So mainly the acidic lava, when it erupts, when the acidic magma erupts, it is called as, it will be mainly violent. Basic lava, it erupts, it's less viscous for gases which is contained in basic lava, it can easily escape. So it will be very less violent. That is, it is quite. But acidic lava, it is very viscous. So it will have the pockets of gases trapped inside. So as these gases, they want to release, huge pressure is there, they want to release, and this being trapped in the magma, they erupt with huge force. They erupt with huge force. As they erupt with huge force, waves will be generated, and those waves are recorded in terms of seismic waves, that is leading to earthquakes. So volcanic eruption, earthquakes are generated. You have as well seen the sound generated when when the volcano erupts violently, and these materials, they are being thrown up in the sky, and to many, see here, for example, this is volcano. When it erupts with force, it can be thrown the pyroclastic flow or the half burnt material that is called a cinder. It is thrown much far away from as well. So it is rocks falling from the sky, solid rocks, fragments of the rocks falling from the sky. Those are called as cinders, half burnt materials. And as well, the ashes. So see what happens, how the volcano erupts. So first, magma is there, it pressure builds there, it pressure is building there as well. Gases are released. These gases are trapped inside this magma. Now, if it is very viscous, what will happen? Huge pressure will be generated. Huge pressure will be generated. Stand up, stand up, stand now, stand now, stand there at the back. Take a book. I said stand there at the back. Do it fast. If you are not paying attention in class, I won't let. Just stand at the back. And next you will be Bhavesh. So just stay quiet. I have seen what you have done. So this magma, since it contains pockets of gases trapped and pressure is being generated, what will happen? It will violently flow. So initially, first the ash is released. For example, ash is released, half burnt metal, and I am discussing it certified volcano as well together. So ash will be, first ash is being released. So it settles down on the sides of the volcano, on the mountain. So a layer of ash is formed. Now with time, pressure is building here, and now these gases as well release with violently. As they release, what will happen? Some magma is thrown up in the sky. So this magma, it contains solid as well as liquid material. So this is semi-molten. So this solid material, this is called as mainly the cinder. This is half burnt materials. This is called as cinders. It will be thrown up in the sky and it may create the accidents on the sides. So, and now it contains steam as well. So these all are released in the sky. So these cinders are the half burnt materials, these fragments of the rock. Along with this ash is around here. Ash size is around sand. It is like sand. Sand is there. This ash, its crystal size is equal. These grains are equal to the size of the sand grains. So around 1 or 5 mm, 5 mm around 5 mm, 1 mm, 1 to 5 mm, 2 to 5 mm. These sand grains. So they are being released and a layer is formed. Now the second layer, lava will be formed. So this will continuously go. Whenever again it erupts, first lava layer, then first ash layer, then the lava layer. So we have the alternate layers of ash and lava. This is called a composite volcano, stratified volcano. Composite volcano or stratified volcano. That is layered volcano. We have ash layer, then lava layer, then ash layer, then lava layer. Ash, lava, like that. Okay. Now see here what more can happen. These cinder fragments of rocks, along with ash, it is called as tephra. This material is called as tephra. Now, and when it flows, that is called as pyroclastic flow. Pyroclast, we have seen the different materials consisting of ash, fragments of rocks. These gas, they all constitute pyroclast. We call it as pyroclastic flow. Since it is released, it will be like sear. It is burning material, half burned material, so it will be shining. So it looks like pyroclast. So now steam is as well released. As it comes in the atmosphere, it cools down. So it may happen, rainfall may happen, or because of this steam, converted into water and mixed with pyroclast. A flow will be generated that is called as lahar. That is called as lahar. We have discussed that in volcanoes as well. So water, it's a muddy flow, kind of a muddy flow. This is okay. This is clear. So along with volcanic activity, earthquakes are generated. If it is very violent, earthquakes may be generated. Now plate tectonics. Tectonics means building activities. That is whenever the plate interacts, some buildings activity may take place. Like mountains are built, folding and faulting. So in tectonic plates, these folding and faulting are parts of tectonic plates. So all the four causes we have discussed, the plate and anthropogenic factors as well. Causes earthquakes. How? Anthropogenic means man-made. Anthropogenic means man-made. Anthro is related to man. It is man-made. That is, humans have made that. How? We blast somewhere, earthquakes are generated, waves are generated. We blast in mines, earthquakes are generated. Or for the construction of dams and all, we blast the mountains, earthquakes are generated, quakes are generated. Grenade as well, earthquakes will be generated. So these all are man-made. These all are man-made. So four other causes: volcanic eruptions, tectonic plates. In tectonic plates only we can take faulting and faulting. They are not separate from tectonic activities. And the last is anthropogenic causes. So these are the causes. How the earthquakes are measured. How the earthquakes are measured. So see here how severe the earthquake is. How severe the earthquake. That is, what is the motion of the earth. When the earthquake is taking place, when these waves are related, how much is the motion of the earth surface or earth. These plates, what is the motion? That is measured in on Richter scale. One scientist was there, Richter, and he has given this scale. It's a logarithmic scale. It is a logarithmic scale. It is in logarithm log values we have taken. So for example, it is mainly 0 to 8.9 plus. It doesn't have any limits, no minimum, no maximum. And it is mainly measured in logs, logarithmic scale it is. So for example, one earthquake is of 3 or severity 3 on Richter scale, other is of 4. So we can say this 4 earthquake having 4 magnitude, it is 10 times more severe than the earthquake which is having magnitude of 3 on Richter scale. 10 times more severe. So based on the severity of the earthquake, it is measured in logarithmic scale, and that scale is called Richter scale. You understood? If it is 7 and 5, so that means this earthquake having magnitude of 7 is 100 times more severe than the earthquake having magnitude of 5. See here, logarithmic scale, how the motion is taking, what is the wavelength, how the motion is taking place of the earth during earthquake, how severe the earthquake is, and how severe we measure how the earthquake has been disturbed, what is the motion of the earth, and that is being measured on Richter scale. On a scientist named Richter, he has given this scale, and this is nothing but a logarithmic scale, that is measures the severity in terms of logs. For example, on Richter scale, if earthquake is of magnitude 3 and another earthquake is of magnitude 4, it means the earthquake which is having magnitude of 4 or severity of 4, it is 10 times more severe as compared to the earthquake having magnitude of 3 on Richter scale. This is clear. Now, Richter scale we have discussed, and what instrument is being used. That is called as seismograph. Seismograph is the instrument used to measure the severity of the earthquake. There is one more scale, that is Mercalli scale. There is one more scale, Mercalli scale. It measures the intensity of the earthquake. And intensity we measure in terms of, see here, we have the landscape. What is the impact of the earthquake? How disastrous the earthquake was, we measure that impact. And that impact is measured on the scale of Mercalli scale. It is measured on Mercalli scale. That is what is the impact of the earthquake. How disastrous the earthquake was. So we have discussed Richter scale, seismometer, seismograph, and Mercalli scale. Now what is remaining? Distribution is remaining. Distribution of earthquake. How the earthquakes are distributed. So see here, we have seen first the ring of fire. We have discussed the ring of fire. Mainly 2/3 of the volcanoes occur in this ring of fire. That is the circum-Pacific belt we have discussed. Starting from South America, Chile, Peru, Ecuador, Colombia, then Central Mexico we have, Central America, then Mexico, then USA on the west margin. Going to Alaska, then Aleutian Islands, Kamchatka Peninsula, then we have the Japan, Charlene Islands, and then little bit South China. Philippines, we have Philippines, Indonesia, going towards New Zealand and those all islands. So it's a kind of ring circuming the Pacific Ocean, the circumference of the Pacific Ocean. This is the ring of the fire. Here the boundaries interact, the Pacific Ocean plate and this American plates, South America, those are plates interact. And that's how the mountains have been formed there as well. And these are the points where volcanic activities have taken place. And these are as well the points, these are as well the locations where the earthquakes will take place. Wherever these plates interact, the earthquakes take. So 80% of the earthquakes take place in this ring of fire. That is where these boundaries, where these plates interact. That is the boundaries of these plates. Where these plates interact. So in ring of fire, 80% of the earthquakes take place. You can see in diagram as well. You can see in diagram as well. Starting from here, ring of fire. South America, North America, then Alaska, Aleutian Islands, see here. Fujiyama we have in Japan. And then going through this, Indonesia, New Zealand on those all. So a ring of fire is there. Along here, 2/3 of the or around 80% of the earthquakes take place in this ring of fire. As well, 2/3 or 80% of the volcanoes as well lies in this region. Most of the active volcanoes are there in this region. Yes, Bhavesh, what's your problem? Nothing, then look front. Put your book on the table and look front. So most of the earthquakes happens there. Now remaining earthquakes, that is 1/3 are remaining. 2/3 we have already discussed. These 1/3 we have discussed volcanoes where they occur. Mid-continental belt, that is transcontinental, that is between the two continents, African and Europe and Asia. That is transcontinental belt. There as well the earthquakes happen. So starting from the Mediterranean Sea, moving towards Arabia, then India, that is Himalayas, Hindu Kush and Himalayas. Here the earthquakes as well take place. These are as well these are the boundaries of the interaction of the plates. Here as well the earthquakes happen. And the last is Mid-Atlantic belt. That is Mid-Atlantic ridge we have. They are the two ocean plates. They are moving apart. They are diverging. As they are diverging, volcanoes erupt and there as well earthquakes take place. Here, these are not much severe earthquakes. They are diverging, so not much severe. More severe in this ring of fire. This is the distribution. Now, what are the impacts of earthquakes? Whether it's disastrous or it can be constructive as well. Constructive how? Okay, we see that one. So first, disaster, how they are destructive in nature. So how they are destructive in nature? Buildings, landslide can happen. See mainly what happens. If some land is saturated with water, now as it shakes, it converts in a kind of a liquid flow. And this land slides from the base. As it slides, it moves down. This is called landslides. Liquefaction, that is called liquefaction as well. Liquefaction, what happens here? Land is there. If it's saturated with water, it converts as it shakes. It converts it into a kind of liquid flow. It removes from the base and it moves down. That is called as landslides. Now, one more very important is tsunami. How tsunami are formed? How tsunami are formed? So that will depend on the kind of fault formed. See, in past around 2014 or something, one in the ocean it happened. That was just this one. That is, the two plates were striking with each other. That's why tsunami was not generated. So, how the tsunamis are generated? So, for example, here the interaction are there. This is one plate. This is other plate. Now, these two plates, tension is there. As tension is there, so see here, what can happen? Either one plate can go up, other plate can go down, or they will interact like this. So one up, one go down. So next time, this plate is pushed upward, this plate is pushed down. So see here, space is generated here. What will happen? Water will try to flow towards it. As all the water try to compile here, as water tries to compile here, all the water will try to rush here, and a wave will be generated. A wave will be generated. This is called a tsunami. Now see what happens to the tsunami. Its wavelength is around 700 kilometers. No, it's around 200 kilometers wavelength. Wavelength is around 200 kilometers. That's not to use. Its crest, that is height generated. It is around 0.5 meters. Just let's say it is around 0.5 meters in ocean. In oceans, it is around 0.5 meters only. So when now it is being recommended, when a tsunami take place, if you are in the ocean, move towards the interiors of the water, not towards the bank, not towards the coast. This is being recommended that always move towards the away from the coast. Why? Just see. So as tsunami is generated, if this is the coast, here the wave height, it is around 0.5 meters, and its speed, it is moving with around 700 kilometers per hour. This is the speed. This is the speed of the wave generated. Now see here, as it reaches shallow water, it will slow down. The speed will be less, it will get slowed down. As it slows down, all the water compiles there. It piles up. All the water piles up, and here the wave height can reach up to 30 meters. Wave height can reach up to 30 meters. So, wave height reach up to 30 meters. So, it will be very disastrous. This is called as tsunamis. It is made up of two words, su plus nami. Su means harbor in Japan, in Japanese, and nami it is waves. You can write it like this as well. Su, na, mi. This is tsunami. Tsunami. It is Japanese. Yes, be quiet. Tsunami. Yes. Now listen here. One more thing. How we can predict tsunami? How we can predict this? See here. When a tsunami is going to take place, this water on the coast resets. It resets. See here what happens. As this fault has taken place, space has been generated, all the water will try to move towards this, all the water. So from the coast, this water will move towards this origin. Now here water resets. So how we can predict tsunamis? If we see on the coast, if water is receding, we can predict that soon we are going to have the tsunami. This is how we can predict. There are some animal behaviors as well we can predict using them as well. Like ducks, they won't go in water. Why? If they go, they will blown up. Tsunami? Yes. Okay. Tsunami, I'll be explaining it again. Okay, listen here. Then fires can happen. Flash floods. Flash floods are there. See here. Flash floods, when which taking place in the just flash of a second. Yesterday I was watching one channel. I don't forget. Yes, Discovery Science I was watching. There was one program. You have been warned. In that flash flood was showing. They were showing the flash flood. So see how the flush are generated. If there is a huge rainfall, if there is a huge rainfall of just 2 minutes, back to your seats. So for example, there is a huge rainfall, and for example, rainfall is of 3 inches or 7 centimeters. Huge rainfall has taken place, and land cannot absorb that much water. So within a very few hours, a huge flood will be generated. That is flush plain. Or during earthquake, what happens? These dams or any, they can get weakened and they can collapse, and this water releases. So within very less time, the whole area will be piled up with water. That is called as flush plains.
Sir, I was asking that we said that there
Thank
is
you,
a
sir.
lot of mountains. So can you explain that?
Thank you. Thank you. Be on your seats.